All right, so I want to show you this one, ED319, and the first link here takes you to the server version if you're using Server 2016. But I think this semester we're mostly using Windows 10. I am. So I wrote a Windows 10 version, and this is the one I just updated to Python 3. So of the two, I would recommend this one, but they will both work. So for this, you need two machines, just like all these Windows exploits. You need a Windows machine to attack and a Linux machine to send the exploit. So let me just shove these instructions to the side. And here I've got my Windows machine. This is just a Windows 10 machine. And as you can see, it's got an IP address there ending in 130. Let's run that again to make sure it didn't change when I restarted it. And it didn't. So it's 172.16.123.130. All right. And I did turn off data execution prevention, which I think was probably the default here. And you can turn off SEH. And again, I don't think you need to do it on a client machine. But anyway, there are instructions here to make sure these defenses are turned off because they would stop this. And let me make sure I'm looking at the right version because I think I got to go to the Windows 10 version and it won't tell you to do that because you don't have to. There we go. Wait, no, it's still wrong. All right, just a minute. This happened to me before. My browser is determinedly sending me to an old link, and I might have to use a different browser to get it to stop doing that. Yet 319B, and when I click it, it does not go to 319B. Boy, it did this yesterday. Let me go to Safari. Safari will show me the actual live link. I don't know why Brave is just determined to show me something that's been out of date for 2 days, but somehow it will not let go of the... This is a fairly common problem I get with websites these days. One of the reasons I use so many different browsers. A lot of them get stuck on old versions of things, and refresh does not seem to convince them to stop showing me the old stuff. So 127. Projects. 319, Windows 10. And there it is. My other browser is just lying to me and ripping me off. This is the Windows 10 version. So it's using Python 3, Windows 10, and a Linux machine. So you don't need to turn off DEP or SEH if you're using Windows 10. Since it's a client version, those things are already not there. So all you need is vuln server, the same program we used before. And so you can start by running vuln server and then attack it from your Linux machine. So let's do that. Yes. There we go. It's moving. Okay. So vuln server is in this folder. And there it is. Okay, so now I'm listening on port 9099 for 9999. And let me make this bigger. Okay. Here's my SSH into my Debian Linux machine. And if I cat SEH1, okay, so here it is, the same old stuff. I'm using Python 3. I have the IP address of the server and the port number. So I connect, and then I'll see a prompt. And does that show where to get a Windows 10 download? Yeah, that's back in an earlier project. Let me bring that up. Yeah, right here. Look at ED32. That shows you how to get it. You can get a free trial version from Microsoft. So that's where you go to get a Windows 10 machine if you don't have one. Good? And so now I send 3551A characters, and then I send BCDE, and then I send enough X's after it to fill it to 4,000. So I've skipped the part we did last time where you fuzz it and figure out where the active ingredient is. I'm just telling you it's at 3551. And this time we're using the gmon function. You may remember there are several different functions in this vulnerable server. Last time we used a simple stack-based buffer overflow. Now we're using an exception handler overflow, so it's a different part of the program you're hitting. So that's SEH1, so I run that. And it says, welcome to vulnerable server. And yes, there we are, it crashes and gives you this error message. So I found a vulnerability, but since I did not put this in a debugger, I'm not really getting much information about why it crashed. So let's cancel that and put it in the debugger. And by the way, one thing you have to remember this time, which is not obvious, is you have to run the debugger as administrator, because later on we're going to use Mona to get some information, and it will try to write into a folder it can only reach if you ran as administrator. So let's run immunity as administrator. I've right-clicked on it, and it will have noticed that eventually. Yep, okay. Run as administrator. And yes. It's the streaming that makes it kind of slow, but this is not terrible. Okay, now I open Vuln server inside here. And it's paused, like it always is when you first open it. So I run it. Now it's running, listening. So now I just send that attack again, which is here. Okay, and so it has crashed, but it's crashed with access violation when writing to something, and this is an exception. Notice it says use Shift F7, 8, or F9 to pass exception to program. So it has hit an exception. It has not, notice it's not showing trying to execute 41, 41, 41, 41 or anything useful yet. It's got some apparently random number here, but it is an exception, so I can pass the exception to the system. So let me get my instructions here. So all right, we've got this stuff all installed. Yep, so first let's look at the exception handler. We can view it with view SEH chain. I said view SEH chain. Okay, and there it is, and I wonder if I can make it bigger. Appearance. Yes. Appearance, I say. There we are. Font. It's ridiculously slow. I think I already set this one. Yeah, I set that one to be bigger. So there you are. You can see this exception handler has been overwritten by my attack, and it contains 42, 43, 44, 45. That's BCDE. So if you remember the structure of the code here, it sent a bunch of A's, then it sent BCDE, and then some padding after it. So this BCDE hit the exception handler address. So that's the point. This is an overflow, but the thing we can reach by overflowing is the structured exception handler. So we do have an address we control here in the exception handler. So when the program hits this point here, let me go back to the default view with the CPU window maximized. Here it says access violation. So if we do press Shift F9 to resume execution, it then proceeds into the exception handler, and now it crashes when executing 45, 44, 43, 42. So now we have achieved essentially the same thing we had before with the buffer overflow. We are now trying to execute code, and the address we control went into the instruction pointer here, 45, 44, 43, 42. So we've got that. All right, so now we have to make a stack pivot. And so what we need to, now we can look at the, let's look at the stack here. here is an address, another address, and look at this. The third item on the stack points to AAAA BCDE XXXX, which is the code we injected. So if I can do a pop return, I will jump to this A and start executing code we injected. So I do have a way to find my way to code we've injected, even though I have address space layout randomization on. All I have to do is find a pop return that is somewhere in code that does not move. That's a stack pivot. So we got to look at the modules with Mona to see what defenses are turned on. Bang Mona, like we did before. Mona modules. Okay, and once again, my font is horrible. There we go. So once again, we're seeing something we've seen before here, the various defenses that are turned on. Notice safe SEH. And the thing we care about now is ASLR. And you see there are two items here which are old code which is not being relocated. And those are vuln server itself and ESS func. But the problem with vuln server is it's loaded at low memory with addresses starting with 0, 400,000. So we can't inject addresses like that without the null byte terminating our string. So the place to attack is again essfunc.dil. And that is loaded at addresses that do not start with 0, and it does not move. Address space layout randomization is turned off. So that's a good start. So now we're going to need to print some logs with Mona. And to see where they are, you go to Options Appearance, and then General and Directories there. And here you see C Program Files x86 Immunity. That's where it's going to write to them. And this is why we had to be administrator. If you didn't run Immunity as administrator, it wouldn't be able to write the logs. But I did, so I will be able to write the logs. So now I can find ROP gadgets. And here is the command that finds ROP gadgets in the ESS func. It is bang Mona ROP minus M for module ESS func. This will find return-oriented programming code that is useful in that module. And won't take too long to do it. I think it's done, and to see the results, we go back to the log window. And you see the ROP generator finished, and it wrote some files to files like stack, pivot, and ROP suggestions, and so on. So we just need to look at those files. So we'll look here. And we have to go to C, Program Files x86. Yes. There we are. Program Files x86, Immunity, and Immunity. All right. And here, I think the one I want is Stack Pivot. Yep. So there it is, stackpivot.txt. So I double click that, and here's the result. Let me maximize it if my mouse will respond. There we go. All right, so here we got the same module information you saw before at the top. That's not very interesting. And here's the stack pivots at the bottom. So here there's quite a few of them. See pop return, various kinds of pop return, pop EBX. Let me see if I can point. My mouse is very slow because of the defects of this streaming stuff. There we are. It's finally responding a little bit. So there you go. There's pop return, another pop return, another pop return. Any one of them is fine. So I'll just use the first one, 625010B4. It has found addresses which will not be randomized and which contain pop return, which will jump back to the code I injected. So that was the only thing I did that for, was to find that address. And now we can view that code. So 625010B4, let's look at that. Let me close Notepad and go back to Immunity and go back to the CPU window, which is the normal view. And now I can go to, I better restart it. Debug, restart. Okay, now right click. Yes. Go to expression, and that's it, 6250 10B4. Remembers from before. So I click OK. And there we are, 6250 10B4, and as you see, that is pop return, just sitting there. So if I put this address in the exception handler, an exception is triggered by this overflow, and then it will jump here and do pop return. All right, so now I can test the attack, and that's here in my SEH2 file. Let's do cat SEH2. All right, so it connects to the server the same as before, and it sends some A's. Then I inject, instead of the last 4 A's, I put in a sample exploit, which is just nop int 3. NID is nop, CC is int 3. That's a break. So this will do 3 nops and then break back to the debugger. And here is that address, 6250 10B4. So you see there is a problem here. I'm able to jump to my injected code, but I only have 4 bytes of code to use, which is an irritation. So this is a pretty limited exploit. So I'm going to have some small code here, but this is just a test to see if it's going to work and see if I'm able to execute the code. So that's what I've got. So let's run that one. If I run this, so it's listening, and then I run that SEH2. Okay, it runs, causes the exception, so I have to press Shift F9 to continue. Now it runs ahead, and it hits a break, which is good. Up here's, if I scroll up a little, I can see the instructions that have just gone by. And as you see, here's my A's, the 41, 41, 41. This is my nop int. So it did jump to my injected code and execute my 4 bytes of code, nop int 3. So I am able to control the address, I'm able to bounce off the stack pivot, and I'm able to execute code I've injected. Now I'm ready to perfect my exploit, subject to the irritation that I only have 4 bytes to use, which sounds difficult, but it's not all that difficult. All right, so, all right. And so what you have to do is you have to find really short instructions. And it turns out that the only thing I can do is use this one. A jump relative 8 is the instruction that is only 2 bytes long, and it can only move 128 bytes. So I have to do it in stages. The winning technique is down here. Put the shellcode before the SEH bytes, then go to pop return, then put a jump to jump backwards 450 bytes to the shellcode. So I have to do you have to do 2 jumps. First I do a jump rel 8 to jump back 10 bytes. Now I have enough in those 10 bytes I can make a bigger jump, rel 32, which will jump back 450 bytes, and that gives me enough room to put in the shellcode. So it's you have to do a little bit more assembly language manipulation than we've done before, but that's the game. And so this is it, SEH3. All right, and so might as well make it bigger. So here's what happens. I have a prefix, which is a bunch of A's. Then I have something that will jump back 450, and as you can see, that is 5 bytes long. It's E9, and all this is like minus 350, a 32-bit number. That's why it's got all these FFs in it. So this will jump, these 5 bytes will jump backwards 350. and I put a NOP break here, so I put in some extra break instructions, these CCs, which would not be used in a real exploit, but they're used for us to view it in the debugger so we can see the steps. So it's going to first go to the stack pivot, which will do pop pop return. That will then run to the jump 8, which will go back 8 bytes. That will go back here, and that will jump back 350 bytes, and that will take me back here to my exploit code. And here I'm just using a bunch of breaks for the exploit code. I'm not putting in Metasploit code yet. I just want to see that it's going to work. So this is SEH3. Let's restart the target. Debug, restart. Yes. And run it. Okay, now it's running. Now I run SEH3. Okay, so the first thing it does is trigger an access violation, which is the exception. So I have to press Shift F9 to continue through that. Now it runs to my exception handler, which I've corrupted, so it jumps to the stack pivot and back onto the stack. So here, there we are. So now it did the NOP and the break. Now it's about to do the jump short, which will jump back just a little bit. So let me just roll this up a little further. All right, so I'm right here at CE. Now I'm going to press F7, take another step. See, that jump jumped back to here, and this jump is going to jump back further, all the way up to here. So now I'm way back where I have hundreds of these CCs. So you can see the first jump worked and the second jump worked, and now I'm in a nice big area of memory under my control where I can put the Metasploit payload. So just as before, we're using Metasploit here again. So generate Metasploit payload, which in this case I used the one you normally want to use, which is a reverse handler. So let me get, wait, this is the wrong set of instructions. Here's the right set of, where's the right set of instructions? Here they are. All right. So there you go. You use again an MSF Venom, but you make a reverse shell calling back to the address of your Linux box and avoiding the bad characters, which are 0, A, and D. That's null byte, line feed, and carriage return. And those are the things that typically will end a string. So copy that Python code and add it into your attack. And that's my SEH4. So let's look at that. All right. So here it is. Let me make it so it fits in the part of the window that's visible. All right. So up here, I just call the right address to connect. Here's the Metasploit generated shellcode. And so now I put in some NOPs and then a break before the shellcode. And so I have the prefix, the NOP sled, the buffer, the jump, the pivot, and the post. And I've left in a few breaks, one here, and one here, which would break real attack code, but it'll make it easier for us to follow the progress in a debugger. So let me run it again. Debug, restart. And run. Okay, and now we run SEH4. And it's right. Okay, so it's already fed it here. So here I hit the access violation. I have to press Shift F9 to pass that to the exception handler. Now it's hit one of the breaks. So I'll roll this back so you can see. Okay, so it's hit the jump short. So now I'm just going to press F7 to step through this. There's the jump short and the next break. Here's the jump long that takes you back here. And now you've got a bunch of NOPs, and eventually it'll run the Metasploit shellcode. Now, before I proceed to the Metasploit shellcode, I'm going to have to start a handler at this end. So that is here. I got to run MSF console. -Q just to avoid printing a big banner that I don't need. And when it comes up, I can execute this stuff. You can't do it all in one go. You have to wait for Metasploit to start before you feed in the Metasploit commands. Okay, now I can feed in the Metasploit commands. All right, that just tell it which attack I'm doing, and I want to reverse shell. And now it's listening on 4444. And now I just let the exploit continue by pressing F9 here. Now it runs ahead, and looks like it hit another int3 command. I guess I'll press F9 again. All right, yep, and that did it. Now you see I'm getting a reverse shell here. You see it's still running. It's kind of slow because it's in the debugger, of course, but it is executing the Metasploit payload. And there you are. Now I have, who am I? Maybe it's uname. I forget what it is. sysinfo is one of them that works, and help works. Yeah, there's Windows. It's getUID. See who I am? Okay, so I'm on the Windows machine. I'm not the administrator. I'm IE user, but so on. I'm in. But I wonder if I can escalate to system. Get system. I think there's probably some defenses to prevent this. Yeah, especially I'm not sure that that's going to work when you're running in the debugger. Anyway, as you see, I get a shellcode. And I think that's it for this one. And there are various flags to turn in on the way. All right. So that's what I wanted to show you. And like I said at the beginning of this course, once you can do a buffer overflow, you can pretty much do them all. They're all just minor variations on the buffer overflow. So I'll stop that recording.